Hello and welcome to my very first repair video. I've got a few other videos on YouTube related to some other interests I have, such as metal detectors and CNC machinery. And I watch a lot of repair videos, such as the Radio Shop, Signal Path Blog is one of my favorites, TRX Bench from over in Europe. I like to watch repairs and the steps they go through and how they come to their conclusions and how they fix things. And I repair stuff myself. I've just never videoed it. So usually test equipment is what I work with the most. So I decided to start maybe and video this repair. This is an HP E3620A power supply. Not really old, but not brand new. Bought this in used, non-working condition. It's not totally dead. The description was it had a dim display, and the output voltages were reading didn't match with what the display said. So this should be a high quality power supply. It's a linear supply. But being HP or Agilent or whatever you want to call them today, they're built really well, and I'm hoping to be able to put this at use in my little workbench here. So I guess the first thing we should do is try to confirm the problem. So let me get a power cord hooked into this, and we'll see what it looks like. I just unboxed it, so I have not tried anything. Okay, I've got the AC hooked into the back of it, and I'm ready to check the DC output. And let's see what it looks like on first power up. Okay, that is a dim display. However, the decimals look brighter. I'm sure that'll become obvious why later maybe, but this is a dual supply. I'm looking at supply 1 right now. I've got that button, even though it's broken, I've got it pushed in and latched. The display says 14.3, but my meter says 11.6. So that's definitely not right. Let's check the other one. Just move over here and pop that in. It says 6.2 on the display. If you can see it, it's very dim. You may have to get a better angle so you can see the display. But the meter says 5.07, so we're a little over a volt off on both supplies. So, well, at least it's not dead. That's encouraging. So let me see if I can maybe get a little better shot of the display for you. Okay, maybe that's better so you can see how dim this display is. I had to turn the lights off. It's weak. So, but at least it's not, at least I can see something. I suppose the next thing to do is just open it up and see if we see anything obvious inside. I doubt it's going to be that easy, but you never know. So here we go. Well, this supply seems to have some catches for releasing the cover instead of screws. So let's see how this goes. If I can do this without breaking it. I don't see any screws. Let me unplug that. I don't know if it's supposed to come up or back or what. Let's see. And my meter goes to sleep. Oh, there we go. So it can go up. That's what it does. Have to really pull those things out far to get them to release. Okay. All right, and we're in. Let's see what we have. Relatively clean. A little bit of dust, but it's not bad. There's nothing obviously burst into flames. I do have a schematic of this main board that I think is reasonably accurate. Thanks to someone on the EEV blog forum for posting that. But I don't think this display board here in the front is included in that schematic. This right here. I don't think that's included, which may be a problem for us later on. But if there's nothing obvious, I have looked at the schematic before I received it, and noticed that there is a circuit that is labeled bias and display. So it fed like, I think it was 2 or 3 voltages to that display board, and one of them was a reference voltage, and the other was like 5 volts for operating it. So I'm thinking that may be a good place to start, if nothing's going to just jump out at us here. So let's go to the schematic and take a look at that. Alright, I know there's a little glare on here. I tried to get rid of all of it I could. But this is the part of the circuit that I'm interested in right now. Problem may not be here, it just looks like a nice place to start. This is labeled display board bias and reference circuit. You can see it generates a +5, a -5 for powering the main logic on that display board. There's also a 4.5 volt reference, and I'm guessing that that's involved with accurately displaying the correct voltages on the front. So I'm real interested to see if this is there and if it's right. So that's where I'm going to start at. See if I can find a parts placement, maybe locate these items on the board. Okay, back on the bench. I've located some test points. I've located the regular circuitry. Right in here it is. Test point, let's see. Test point 10 is +5. Test point 9 is ground. Test point 8 is -5. So let's turn this on and see if we have any of those. Let me get some AC voltage back into this thing. Okay, and power it on. Now I've got my ground lead on the frame over here, but I'm hoping that's good enough. We'll find out. Test point 9. Well, maybe that's not good enough. This is an isolated supply. I should have known better. So, I don't read anything. Well, 9 is ground, so maybe that's why I don't read anything. Let's try that again. Let's go to 8. Nope. Okay, so let's put the ground lead on test point 9, like it says. Test point 8, -4.78. Not bad. That should be the -5. Test point 10. Ooh, 3.8. That's not good. That's low. And that also feeds this reference IC right here. This is that, I'm calling it a reference IC because that's what it's usually used for. It's an LM336BZ. And it's normally a 2.5 volt precision regulator. But in this case, it does have an adjust pin. So in this case, they are biasing it up to 4.5. But that +5 is what feeds it. It's just not going to cut it. 3.8. So this should be the 3.78 there. This other side would be that precision 4.5. 3.6 because she doesn't have enough to work with. So, which IC is the +5? U16 right here is a 7805. Yeah, there's that 3.8 on the output. What's the input getting? If I can get on that without slipping. 5 volts coming in. Well, that's not going to work too well. 5 volts coming in, you're not going to get 5 volts out. You're going to need at least 7.5 or so. So, it appears that they're using just half-wave rectification. Tell you what, let's go back to the schematic and we'll look at what the input circuitry is. Okay, we're back at the schematic. You can see the input to that regulator. They have a separate tap over here to generate the plus and minus 5. I don't believe the transformer is a problem because the minus 5 is fine. Now, there is a 1 ohm resistor in series with that plus 5, the positive supply. Just the 1 ohm, there's a diode to rectify it, there's a couple of filter caps. That's all there is. There's not a lot to go wrong there. So let me check. I may check this resistor first. And the diode, I'll check it with a meter, but it's obviously not open. We wouldn't have anything. That filter cap now is a good suspect given the age. The filter caps are one of those things that they have a lifespan to them. They do not last forever. So let's take a look at that 1 ohm resistor. Now the other option is that we have a large current draw. As I was saying, one option is that we have a large current draw out on this plus 5 volts. I don't really think that's the problem though, because if that were the case, this regulator would just simply, throttle back the output voltage, and the input voltage would not be low. I wouldn't expect it to anyway. So I don't think that's the problem, but they will fail. Let's just go back and check some things we're suspecting, like that 1 ohm resistor. All right, back on the bench here. R51 is that 1 ohm resistor, and I'm going to try to keep my head out of the shot now. R51, let's see, here's the transformer. There's R51 down in there. Maybe kind of hard to see without a lot of light. Let me try to get some more light on that. Okay, I hope you can see that down there. There's R51. Now there's some discrepancy between the schematic and the parts list. The schematic says it's a 1 ohm. The parts list says it's a 10 ohm half watt. So, not sure what's going on there. Maybe it's just one of those is wrong. Let's find out. Okay, let's reach over in here and see if we can measure this resistor. Uh, 1.05 ohms. So I'm going to say it's a 1 ohm and it's perfectly healthy. So let's take a quick look maybe with a scope to see if we see a lot of ripple on this supply. Okay, what I've done now is I've hooked up my oscilloscope. I connected the ground to the tab of that 7805 because that is the common point. And I've got the probe hooked to the cathode of CR17. So now I'll show you what that looks like. Okay, let's turn it on now and see what the scope says. Yeah, there is some sawtoothing there, but not as much as I was expecting to see. Let's see, how much do we have? Measure voltage, peak to peak, 280 millivolts or so. Not as much as I was expecting to see. That's odd. So I'm not so sure about the filter cap now. I was expecting to see several volts of ripple, but it's just not there. And yes, I just checked. The probe is on ×1, so that's not an issue with ×10 ×1 on the probe. There's just not a lot of ripple there. Okay, I'm looking back on the bench again here. I'm a little curious how much input voltage there is on the -5 side, the side that's working normally. Let's see, test point 9 was our reference. Test point 9. And yeah, U15 is that negative supply. Negative 5.3. Now, where's, it must be, yeah, CR18 is the rectifier for that. Let's see. My backlight back on. 9. CR18. Test point 8 is the output. So minus 4.7 out. It's actually a little bit low. Not sure if I can get to all the pins of that minus 5 volt regulator, not from this side. Let's see what I can get. 4.7. And try not to make a mess here. 5.3. And that must be the reference pin. So only 5.7 in, 5.3 in, 4.7 minus 4.7 out. That's not sounding good. Just noticed how pinched these AC wires are here. I hope they're not hurt. They've got a tubing over them, but they have been pressed against that windings of that transformer for a while. So I'm hoping I don't have a bad transformer here. It just seems really, I mean, plus and minus are weak, and that minus 5 would probably be low output if it had more load on it. So I don't know what the AC output voltage should be. Might try to give that a measure. Test point 9 is the common point. Test point 9. And then basically one side of that 1 ohm resistor would be the other. Right here. 4.4 volts AC. It does seem a little odd. I was just noticing the AC input taps on this thing. Would you believe it? It's set for 230 volts. Wow. Now that makes more sense. Let me see if I can get you a better shot of this switch. Okay, here's a better shot of this switch. You can see where it should be switched for 115, which is what it should be for where I am in the United States. And you can see it is set for 230 volts. Now, are we really that lucky that that's the only problem? And how did it get switched to that? Unless this came from overseas, maybe. I'm wondering. Here's a shot of the rear of the unit where you can see it's clearly marked to be 115. Of course, that just means that's how it left the factory. It doesn't really mean it was that way its whole life. But it originally was 115 volts, but at some point it got switched. Okay, well, I flipped the AC transformer tap switch, and well, there you go. The display looks so much better. I'm looking at supply number 2 right now, which is displaying 5.57. My meter says it's 5.6. Let's see how she adjusts. Nice and smooth. Multi-turn potentiometer there. And yeah, I may try to, I see some, on the back of the display there's some potentiometers, I'm guessing for trimming out the display, the displayed voltage. So I'll probably tweak those a little, but she's, pretty darn close. That's supply 2. Let's take a look at supply 1. And I may have to see if I can find a switch or a switch top, because it has broken off. and not enough left sticking out to actually be able to do it with your finger, unless you have really tiny fingers. You have to have something to push up in there to make it latch. But look at that, 12.54 on the display, 12.6 actual output. I'll take that. And this one also runs up to 27. And see how close to 0 she goes. Down to 0.02, which does match the meter there. So she's working. I have not put a load on it, but I will, and I have no doubt it's going to work fine. So, not really much of a repair, I can't say. Not what I had in mind for my first repair video. I mean, we never even fired up the old soldering iron over there. So, I mean, technically, yes, it's working. We have a working piece of equipment, but and some of you who are familiar with this particular supply may have noticed early on that switch is in the wrong position, but I didn't. Wasn't expecting that, and I can't say I've ever had that happen before in anything I've ever bought like that. So anyway, but I'll take it. She's working, and it's a nice little supply. I may have to do something about this switch right here. I'm not sure if that part's still available. Maybe. I've got to have a parts list. So maybe I can come up with a part number from Agilent, Keysight, whoever they are today. So, well, hope you got something out of it. It was not quite what I intended, and I hope maybe my next one will be better and actually have something with broken parts in it. So that's all for now. Thank you. Thank you for watching.